Welcome back, everybody. Section 6.2 is more trig fun. Solving trig equations, but make them medium level. So what's going to be a little more challenging is that we'll need to either use more sophisticated algebra or use some trig identities. So this again is going to be find all solutions in the interval from 0 to 2 pi. So as soon as you see that, you should think, oh wait, is my calculator in radians? Okay, good, it's in radians. All right, for example number 1, 2 cosine of x plus tangent of x is equal to secant of x. So one of the most important ideas when solving trig equations is you need to get one trig function equal to one number. So somehow we have to change all of this so that it's just one trig function. So we need to use some trig identities, like tangent is sine over cosine, and secant is 1 over cosine. And this one can stay the same. Now what I want to do is eliminate these fractions, or eliminate the cosines. So multiply both sides by cosine of x. So then this one will leave, when you distribute, will leave 2 cosine squared. When you distribute this over here, the cosines will cancel, so it's going to leave just sine of x. And then on the right side, these two will cancel, it just leaves 1. Now we need to get this to have just sines in it or just cosines. Well, with a cosine squared, over here on some scratch paper, I know that there's an identity which says sine squared plus cosine squared equals 1. Then if I want to know what cosine squared equals, subtract sine squared from both sides, so cosine squared equals 1 minus sine squared. And that's what we're going to use right here. There's still going to be the 2 in front of it, but then cosine squared gets replaced with 1 minus sine squared. And then distribute the 2. And now make it equal to 0. So subtract 1 from both sides. So this, I'm going to put that first. Negative 2 sine squared. And then the plus sign. And then when you subtract 1 from both sides, it's going to leave 2 minus 1, so it's going to leave 1. Okay, and then this one could be factored. Although when I factor, I prefer to have the leading term be a positive, so I'm going to multiply everything by a negative 1, or in other words, change all the signs. And then factor. So this is going to factor. And in order to get a 2 sine squared, that would come from having a 2 sine of x times another sine of x. And then in order to get a 1, that would come from a 1 times a 1. And then these two signs need to be plus and minus. And then if you check the middle term, this would be a positive 1 sine x, and then this would be minus 2 sine x, which leaves behind the minus sine x. Then set these equal to 0 separately as two separate problems. So it's going to say 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. Then continue on another page. So with this one, you could subtract 1 from both sides. 2 sine of x equals a negative 1. And for this one, you could just add 1 to both sides. So there's the two equations. With this one, just divide by 2 on both sides. Sine of x equals negative 1/2. And this one was already done. So when does sine equal 1? So here's the sine graph from 0 to 2 pi. In the middle right there, that's pi. And then when is it equal to 1? So that's this point right here. And that's in the middle, or between 0 and pi, so that's pi over 2. So x equals pi over 2 is one solution. For this one, it's going to have two solutions. One solution will come from taking sine inverse of negative 1/2 sine inverse of negative 1/2, and then divide that by pi and change that to a fraction. So it's negative 1/6 of pi. X equals negative pi over 6. But of course we need the two positive solutions. So the sine graph goes like this. Right here is 2 pi. In the middle is pi. And then on the y-axis, where is it equal to a negative 1/2? So right here is negative 1/2. And if you go across, there are two positive solutions. One that's right here to the right of pi, and one that's right here, which is to the left of 2 pi. And this pi over 6, you can ignore the negative. This pi over 6 is telling us this gap is a length of pi over 6. So this one is to the right of pi, so that's going to be pi plus pi over 6. This one is to the left of 2 pi, so this is going to be 2 pi minus pi over 6. So for this one, it's going to be 6 pi over 6 plus pi over 6 equals 7 pi over 6. And for this one, it's going to be 12 pi over 6 minus pi over 6 equals 11 pi over 6. And so it turns out there's actually 3 solutions. Now I'm going to graph it and see if I got these right. I don't necessarily need to check all of them, but I'm going to check this one, 7 pi over 6. So graph the original problem before we did anything to it. So one graph is going to be 2 cosine of x plus tangent of x. And the second graph will be secant. Well, my calculator doesn't have secant, so I'll need to use 1 over cosine. The window goes from 0 to 2 pi. Right now, the y's are going from negative 8 to 8. I think that'll be enough to see the graph. Let's see. So here goes the first graph. And then the second one is going to be red, and we're looking for where they intersect. So it seems like there could be one solution right there, one right there, and one right there. So this one is, I think that's going to be the 11 pi over 6. So since that's the easiest one to see, I'm going to check that one. Trace 11 pi over 6. Yes, that's correct. What about the 7 pi over 6? Oh, I didn't see that one at first. Well, good thing I checked my answer. And so those two are correct. And then there's also the pi over 2. Pi divided by 2. Ooh, good thing I checked my answer, because actually it's undefined at pi over 2. So, good thing I checked. Turns out that this one, the function's not even defined. So even though I did the work correctly, I got this extra answer, which is not actually part of the answers. So the final answer is just those two right there. Now what happened is there's this asymptote right here at pi over 2, and I was thinking that they intersect right there, but they don't. They're just close to each other. The only intersections are right there and right there. Okay, then example number 2. So again, find all solutions in 0 to 2 pi. Example number 2, how about sine of 2x minus cosine of x equals a 0. So as I've said before, you need to get just one trig function equals one number. This has two trig functions, so we'll need to use a trig identity. Another important idea is that the arguments need to be the same. So if this says x, I need to have this say x, not 2x. So we need to use a trig identity for sine of 2x, which is actually personally my favorite trig identity. I don't really know why, but I really like this one. So use that trig identity. And then it's still minus cosine of x, and it still equals 0. And now that we've done that, this has cosine and this has cosine, so we could factor out cosine. And then it's going to leave 2 sine of x minus 1 equals 0. After it's been factored, set each factor equal to 0. So basically taking one big problem and separating it into two small problems. So this one, I could even do that without a calculator, because I know the graph of cosine looks like this. Right here is 2 pi. In the middle is pi. So where cosine equals 0 are these two dots. And this one is at pi over 2, and this one is 3 pi over 2. So there's two solutions. X equals pi over 2, x equals 3 pi over 2. And then for this one, add 1 to both sides and then divide by 2. And that will leave us with sine of x is equal to a half. So the sine graph, of course, looks like this, up to 2 pi. And then when is it equal to a half? So from the y-axis where it equals a half, draw a line straight across, and there's going to be two solutions. The solution that's closest to the origin, the calculator will find that when we do sine inverse of 1/2. And then divide that by pi, and convert that to a fraction, it's 1/6 of pi. So this one is pi over 6. And then this one is to the left of pi. So that means it's pi minus pi over 6. And that equals 5 pi over 6. So it looks like we get a total of 4 solutions, including pi over 6 and 5 pi over 6. Now I need to check it and make sure that those 4 answers look correct. So graph the original function. So that's sine of 2x minus cosine of x. And then it's saying when does it equal 0? So that means when does it cross the x-axis? So it looks like my y values are too big. I'm going to change that. How about -2 to 2? So there's 2 answers so far, 3 answers, and a 4th answer, and that's it. So 1, 2, 3, 4 answers. So 5 pi over 6, that's the biggest one, so that should be that one. At least I think it's the biggest one, isn't it? Yes. No, actually 3 pi over 2 is. 3 pi over 2 should be that one. Trace 3 pi divided by 2, that one's correct. Pi divided by 2, that one's correct. Pi divided by 6, perfect. And 5 pi divided by 6, excellent. So all 4 of them are correct. Keep all 4 of them. And then one more medium one. So this is example number 3. Again, finding all solutions from 0 to 2 pi. How about cosine of 2x plus sine squared equals 1? So we need a trig identity, and we need a trig identity for this one, because we need it to be functions that just have x, like this one does. So over here on some scratch paper, I'm going to work out cosine of 2x. The trig identity is that it's cosine squared minus sine squared. And there are actually 2 other versions of this, an identity for cosine of 2x, but I'm sort of liking this one, because if I use this one, it has negative sine squared together with that positive sine squared. They're going to cancel. Ooh, I like it. So the red is the action. So take this action. Replace cosine of 2x with cosine squared minus sine squared. And then just copy down the rest of the problem. And then these 2 will cancel. So what it leaves is cosine squared equals 1. Now to get rid of the square. So take square root of both sides. And when you do, there's 2 answers, plus or minus the square root of 1. So then it says, when does cosine equal either positive or negative 1? And I believe I could do that without a calculator. So here's the graph of cosine. It's equal to 1 right here, and it's equal to negative 1 right here. So if we're going from 0 to 2 pi, there's actually 3 answers. So right here is when it's equal to positive 1, these 2, and right here is when it's equal to negative 1. So the answers are going to be 0, pi, and 2 pi. That one wasn't too bad. Then I want to check and make sure that I got it right. So cosine of 2x plus sine squared. So the calculator doesn't allow me to write it like this. It wants the square at the end. So you put sine of x, close the parenthesis, and squared. So that's the calculator's way of doing that. And then when is that equal to 1? So take a look, and here goes the left side. That's graphed in blue. And then it's going to make a line straight across when it equals 1. And there's 1, 2, 3 answers. Trace, 0, yes. And pi, correct. And 2 pi, oh. So I mentioned this before, but what happens is, so put go to, and it says it doesn't like the 2 pi. So what happens is when you adjust the window, and right here when you put 2 pi, that is perfect. But as soon as I move the cursor, it puts a decimal approximation. And that's actually smaller than 2 pi, so it now won't allow me to type in 2 pi. So if you just put something bigger, like 6.5, and then regraph it, then it'll work. So now the graph is extended a little bit farther, so now trace, and now I can plug in 2 pi and see that that answer is correct. So these are the 3 solutions. Okay, until next time.